Roman engineering secret we forgot. Dome geometry explained. Quick recap. Last time we saw the Pantheon still standing after 2,000 years, while modern houses struggle to make it 40. Today I'm going to show you exactly why curved structures outlast everything else. And it comes down to two things: materials and geometry. The materials. When engineers build something that cannot fail, they make very specific choices. Two materials dominate high-performance construction. Concrete handles crushing forces. Steel handles stretching forces. Each material works best where the other is weak. Concrete can easily handle crushing forces, but not stretching forces. Steel is very strong when stretched, but buckles and bends under compression forces. Together they create a better construction material, reinforced concrete. That's why they're used in every critical structure we build. Dams, bridges, tunnels, foundations, because everything else is far less sturdy. But materials are only half the equation. Take a sheet of paper, lay it flat and it can barely support its own weight. Same paper, same material. Curve it into an arch, now it can hold books. The material didn't change, the geometry did. How curves work. Remember this egg. When the load pushes straight down, the force doesn't concentrate in one spot. It spreads around the curve. A dome works the same way. Instead of flat walls and flat roofs that bend and pull at their connections, a curved shell spreads the load evenly. No corners concentrating stress. No seams trying to separate. The forces flow through the curve and down into the foundation. Here's why that matters. A flat concrete roof has to resist bending. That requires thickness, heavy reinforcement, more steel. A curved roof turns that same load into compression, which concrete handles naturally. Same strength, less material, lower cost. This isn't theory. The Hoover Dam uses a curve to hold back billions of gallons of water. The water pressure spreads around the arch instead of pushing against a flat wall. The Pantheon's dome is 142 feet wide, no columns holding it up. The curve does the work. Every major cathedral, every bridge that's lasted centuries, every monument still standing, they all use the same principle. Curved geometry turns forces into the structure's strength. So we know it works. We know why it works. The question is, how do we bring this back? How do you build a 2,000-year structure using modern materials and modern methods? I'm going to show you exactly how it's done.